This video is about frequency, wavelength, and velocity. We've talked about the period of a wavelength. The period is measured in time. It's the time required for one complete wave. It's represented by the capital letter T. The wavelength is the distance measured in a distance, so it's the length of one complete wave. It's called the wavelength, and it's frequently represented by this Greek letter lambda. The amplitude is the distance from the center line or midline to the peak, or the center line to the trough. It's going to be the same to peak or trough. It's represented by the letter A. There's a new one, frequency. The frequency is the number of waves that pass through a given point on the time axis each second. That unit is important. So the frequency is 1 divided by the period. There's that equation again. The frequency is 1 divided by the period. Frequency is measured in hertz, and hertz is 1 cycle per second. This should make sense because period is measured in time, so in seconds, so frequency is measured 1 divided by seconds. Remember your metric prefixes. So if we're talking about kilohertz, that's the same thing as 1,000 hertz, and 1 megahertz is the same thing as 1 million hertz. Let's find the period, so find T, of a wave whose frequency is 1.1 megahertz. I'm going to write this as 1.1 times 10 to the 6th, and this equals 1 divided by the period. To solve this, I'm going to multiply both sides by T, and then divide both sides by 1.1 times 10 to the 6th. This becomes T equals 1 divided by 1.1 times 10 to the 6th, which on my calculator becomes 9.090909, so repeating, and then it has E negative 7. This means my answer is 9.09 times 10 to the negative 7 power in seconds. One final equation. The velocity, v, equals the wavelength, lambda, times the frequency. So the speed that something travels at equals the distance it takes to complete a period times the frequency. A local radio station broadcasts at 1,500 kilohertz. So just right off the bat, I'm going to change that to just hertz so I can work in seconds because I see my other unit is in seconds. So I know that there's 1,000 hertz in a single kilohertz. So I'm just going to move that decimal over 3 more places. 1,500,000. What's the wavelength in meters? So I'm solving for lambda of its radio waves. And radio waves travel at the speed of light, which you are going to need to know for some of the homework, 3.0 times 10 to the 8th meters per second. So if velocity equals the wavelength times the frequency, we have 3.0 times 10 to the 8th power equals the wavelength, lambda, times 1,500,000. Divide both sides by 1,500,000, and my calculator says that becomes 200 equals lambda. Let's take a quick look at units. The speed is in meters per second. The frequency is given in hertz. Hertz is the same thing as saying 1 divided by seconds, because it's cycle divided by seconds. So our units are in meters per second divided by cycle per second. Dividing fractions, I'm just going to multiply by the reciprocal. So we have meters per second times second divided by 1. The seconds simplify out and we're left with meters. Our answer here is that the wavelength is 200 meters long. Thank you.